Okay, so so starting over again. Today we will be learning about LaTeX, the standard typesetting program for mathematical documents. So now I'm going to share my screen with you. Okay, so let me just go through these steps one more time. So what you're going to need to do is go to overleaf.com. I'm going to delete this real fast. So overleaf.com, make an account, sign in, and then go to new project, blank project, and call it maybe like homework example, create. And then you'll see something that looks like this. Go over to Blackboard after that, course content, and then select all of this text here in this one post. All right? Copy that, go back to your page here, delete all of this, paste in what I gave you, and then click on recompile. Okay, so once you do this, you're converting this LaTeX, which is essentially code, into a PDF. So all of the mathematical papers that you might have seen, or some of the textbooks that you use, were written in LaTeX. So for the professional mathematician, LaTeX is the standard way to produce PDFs. Okay, so I know not everyone in this class plans on going to graduate school, but I know that some of you do want to go to graduate school. If you do end up going to graduate school, knowledge of LaTeX is a must. Like all of your major documents will be turned in using LaTeX. For example, your thesis will be written in LaTeX, whether that's a master's thesis or a PhD thesis. But then also, it just makes the math look nice. And to be completely honest, this will insert some type of bias on your professors. If you turn in homework solutions written in LaTeX, the professor will know ahead of time that you put in some effort into what you're doing, and they'll have a favorable outlook on your homework even before they look at it if it's turned in LaTeX. So a way to get on your professor's good side as far as grading goes is to learn LaTeX early on, and then your senior level classes start actually using it. And Overleaf makes this really easy. So if you're using Overleaf, just take always just start with this code that I gave you. You don't have to memorize anything. Just open a new document and paste it in, and then you start with a template here. So how does this work? So up here are just packages that I think they're like the bare minimum packages that you'll need. So the backslash and the name of the stuff is just things that you really don't need to worry about right now. However, I did post a link to this website here where you can read about what LaTeX is and understand exactly what these calls are going through here. Okay. But again, I used LaTeX for years without ever actually learning the super details of it. I just had a template, kind of like what I posted on Blackboard, that I would always, whenever I started a new project, I would copy and paste those into a LaTeX editor like Overleaf, and I would just use the same things over and over again, and I got used to it. So you can read about these things on overleaf.com, the link that I gave you. Here, I'm just defining environments for theorem, propositions, corollaries, and lemmas, and we'll talk about that in a moment. So here, this is basically like what you'll need to start changing when you're doing your homeworks. So for example, the title here, you can just come in here and just say your title. So like maybe like homework number 1 or something like that, or homework 1. And then you recompile it by clicking right there, and then you'll notice that the title changed, right? So then the author, you just put your name, right? So if you change this, it will change. So if I just say, like, I don't know, and then recompile, you see that the name goes there, right? So just put your name in, and so that will, so that's pretty easy, right? Like now that you have this template, you can just come in here and type there and do your things. Okay, so here is where you actually enter. So see this begin document right here? This is where you enter into like the main portions of your LaTeX document. And then here you have the end document, which says that you're no longer in the main portion of your document. So um, so let's go ahead and like look at what this section is here. So backslash section, and then you can give it a title, introduction or something. Put that in the curly braces, and then if you go to recompile, you'll see that it makes like section 1, introduction, right? Oh, by the way, the percent sign, this stuff here, this is just comments for you to look at. So percent signs are just comments. It doesn't appear here. So notice that I just commented out this section here, and if I recompile, it goes away. So by default, when you do sections, I don't know, like, so I'm just like typing whatever. By default, when you start putting your sections in like this, it will label them 1, 2, 3, so forth and so on with the title that you give them. But you can override that by using this syntax here, by putting a star after section, and then inside the parentheses, put what you wanted to say. So now, when you put the star there, it won't number them anymore. It'll be specifically what you put in the curly braces. So if I compile that again here, we see homework solutions is what it is called. So, and then you can type underneath here just like normal. In this section, we give solutions to various groups given in class, or something like that. And then we compile it, and you can see that it automatically puts in that text underneath homework solutions. Okay. So here, subsection, again, subsection is just like section, but it will like sub-number the sections. But you can override the numbers by putting a star and then curly braces and put what you want to call it. So like, for example, problem 1. Okay. So problem 1, and then you can start putting your problems. So let's go into what's going on here. Just going to kind of put that away for now. So ignore that for now. New page just takes all this stuff and puts it on the next page, and we'll recompile that. All right, so suppose that we had a problem, let's say, let me pick one that we did. Let's see. Okay, suppose like the problem was that if n and m are odd integers, then n is an odd integer. So if I compile that, we see that this is what it looks like. And now notice that the n and the m, and then the n times the m, that text looks like all the other text in here. Now, when we're writing mathematical documents, we don't want to do that. We want to distinguish that this is a mathematical n representing some quantity, and this is mathematical. So the way that we do that is we enter into math type. And you can enter into math type by putting a money sign, dollar sign, and then closing it off. Now notice I did that only around the n. So if I compile this again, notice that the n looks a little bit different now, right? Looks more mathy. So let's do that to the m and now the n and the m. So put that inside of math type, and then put this in type like that. Okay? So now we can distinguish the mathematical objects or quantities from the actual text. You can see that, right? So now if this was a homework problem and we were asked to prove this, we could now write a proof. So the way that we do that is we enter into proof mode. So backslash, say, begin proof, and then in the curly braces. And now, if we begin an environment, sorry, that should be proof. So we're beginning the environment called proof, and we're ending the environment called proof. And inside of here, we're going to write our proof. Okay, so let's go ahead and prove this. We should be able to prove this. So we can prove this using a direct proof. So let n, notice I put n inside of math type. So let n and m be odd integers, and then period. And then let's see what that looks like. So see, now we have the proof environment here. We're inside of proof, and then we start our proof. And then by default, when we exit the proof over here with the end part of it, it will put a little QED box for us. Okay? So let's continue the proof. So let n and m be odd integers. So then we can use the definition. So then there exists, or actually let's use by definition there exists. So by definition, there exists. So I'm going to type this first and then I'll explain it. N, comma, m, backslash n, math, db. And with that, n is equal to, oh no, sorry, not n and m, let's say j and k. So that n is equal to 2 times j plus 1, and m is equal to 2 times k plus 1. All right, so let's compile that and see what it does. Okay, so right here is probably where j comma k integers. So right here, this probably looks confusing. So just to illustrate what this is, I'm going to say, okay, if I do a capital Z in math mode here, outside of the proof, it makes a Z like that. But if I want the mathematical Z with the double down, I would do backslash math dd, and then put the Z inside curly braces. And then it becomes the mathematical Z. Just like if I wanted the symbol for the real numbers, I would do math mode backslash math dd capital R. Right? Now if I do that, you see the mathematical R right there. If I wanted the natural numbers, I would do mathematical or backslash math bb in. Okay. So so j and k are in z, so that's how I remember this. backslash n gives you the epsilon to denote, or the reverse epsilon to denote element of z. So j, k inside of math mode are n, which makes this symbol right here, math bb z, which is the integer z. All right, and then so that, and that. Okay, and it might be useful for you to just have like a LaTeX cheat sheet handy, maybe easier one to look at. This one, yeah. So you can come over here and you can see all the symbols that you'll want. Like you can see like division, not equals to, so backslash ne, less than or equal to, greater than or equal to, approximately, infinity, dots. All of these symbols you can do by just like backslash and then the name of it inside of math mode. All of your Greek letters are easy to access by just doing backslash the name of the letter. So like if I come over here and I do like math mode backslash alpha, and then compile it, you get the alpha symbol. Or you do like backslash sum, and we'll do some more as we keep on going. Okay. All right. So let me just get rid of those symbols. Okay. So next thing I need to show you to do is how to format equations that that will go vertically in your document. So now we've done our definition of the proof. So now we need to do a little bit of algebra, right? So therefore, so in the code that I sent you, I would suggest just copying this business here and putting it there. And then I'll explain what's going on in a moment here. So, so what was n? N was 2j plus 1, 2j plus 1 times 2k plus 1. Okay. So let me just run this real fast. Okay, so what's going on here is you can begin an equation with this, right? And then in order to get like something equal to something, and then you want equals going down like this, you can use split after that, which again, just copy it and paste it in and you'll see what I'm talking about. So let's go ahead and do the algebra here now. So this is going to equal, what is it? 4jk plus 2 times 2j plus 2k plus 1, right? Now, it looks kind of strange right here, but notice like, okay, so we have left-hand side and then the and equals right-hand side, and then these two backslashes here. And then there's nothing right there, and then and equals the right-hand side. So if I like, for example, if I put like an X here, what do you think would happen? It's on the left-hand side, right? So the and equals is splitting to the left and the right. So before and equals is left, after and equals is right. So there is no X there in the proof, but I'm just explaining to you how this is working. Okay, so we're trying to show that n times n is odd, so we need to have one more line here. So the way that we make a new line is we just do the double backslash. And then do the and equals again. So if we factor out a 2, we get 2 times 2jk plus j plus k, and then plus 1, and then there. We compile. So we see that we add, by doing the backslash, you entered a new line, and there's still nothing on the left-hand side. But on the right-hand side, we have this, which is exactly over here. Okay. So now that we're done with that, we exit out of that equation, and we'll say, so we need to just confirm that this is an odd integer. So we can say since 2jk plus j plus k is in, oh, I forgot to go into math mode. There is in mathbv z n times n is odd by definition in proof. Okay, so that finishes the proof. Let me get rid of this new page now here, and this would be like a different problem. So I would do subsection problem 2. So then get rid of that. Okay. So you can see how this is starting to look kind of nice, right? Like problem statement, proof. Problem statement, proof. Okay. So for your first exam, and actually all of the things that you turn into me in this class, I'm going to ask that you turn in these problems using LaTeX. Okay. If you don't use LaTeX, I'm going to deduct immediate 15 points, or 10 or 15. I haven't decided yet. So technically, you can still make a passing grade, but if you're not attempting to use LaTeX, then it's going to be hard to make an A. Okay, so let's look at another proof. Okay, so by the way, if you want to like just make a new page, just do backslash new page. All right, so let's look at another problem. So subsection star, we'll call this problem 3. So if n is rational and n is irrational, then n plus m is irrational. Again, so if I compile this again here, we'll see that it didn't appear on this page. If I scroll down, I see that it appears on this page. Okay. So let's go ahead and do this and say, let's enter into the proof mode. So begin proof. Okay. So we're going to prove this by way of contradiction. So let's go ahead and say that. So by way of contradiction, assume n is rational, m is irrational, and n plus m is rational. So this is proof by contradiction, right? Because the original statement has that the conclusion is n plus n is irrational, so we're going by contradiction, so we're assuming that it is rational. Okay? So now we need to cite the definition of being rational. So then by definition, there exists, I don't know, A, B, C, and D that are in that are integers, right? So that n is equal to, now this isn't too confusing, but it might throw you off at first. We need to write a fraction. So the way that we write a mathematical fraction is by doing \frac. So, and then two curly braces. And in the top, the first curly brace, that's the numerator. The second curly brace, that's the denominator. So that, and n plus m is equal to \frac c over d, where b is not equal to 0 and d is not equal to 0. So let's see what all this business made. So there goes the fraction business right there, right? In the fraction business there. So I actually, when I'm putting fractions into sentences like this, you can get away, and I prefer doing it like this. Right, like that just fits in the sentence better. But know that, and this would be C over D. But we will use fraction whenever we're looking at equations that are centered. All right, so now we need to, okay, therefore, so now we need to do the algebra stuff. So the way that we're going to do this is that we're going to begin a line with a star. So we've entered in there. All right, so let's say, so n plus m is equal to, well, and equal to fraction of c over d. Okay, and then I'm going to go to a new line by doing two slashes like that. And then I'm going to replace n by what it was. So this will be fraction of a over b and equals fraction of c over d. So let's just compile this and see what it looks like. I'm missing something somewhere. Begin a line, end a line. It will give you an error sometimes. There, no, that fixed it. But now I need the plus m. There. So see how now we put something on the left-hand side of the and equals, and it appears here. So n plus m is equal to that, which is the same thing as that. So we need one more line, or maybe two more lines. So now we have m and equals fraction of c over b minus fraction of a over p. So let's see what that did there. Maybe just subtracted. And then we need one more line. Say that m is equal, and equals fraction of c times b minus a times d over pp. Okay. So it's all been aligned up. So then this shows here, so since CB minus AD, comma, BD are rational numbers, they're not rational, integers, since those are integers, and BD not equal to 0, n plus, no, m is rational, a contradiction. Okay, so that's how you can align equations where there's things on both sides of the equation. Okay, so I encourage you now to, so I'll go ahead and copy. No, I think what I gave you is good enough to start with. So I encourage you to take the rest of the class period to type up some of your notes in LaTeX. So go make a Overleaf account, copy paste my stuff into your blank document, and then try to translate what you have in your notes into LaTeX code. Okay? So that will be it for today. I will be around my computer for the next like 30, 40 minutes. So I highly encourage you to start this process. And if you run into any errors, just email me and I'll get back to you as soon as I can. Okay? Make sure to give it a title, put your name, make sure it looks all nice. And then you can even email me. You can download the PDF just by clicking here. You can download it, and then you can email me your PDF, and I can tell you if it looks good or not. Okay? That way we can get you ready to write up your first exam in LaTeX over the next like week or so. And next week we'll have a review about proving techniques as well as LaTeX symbols and how to do this. So everyone stay safe, and hopefully I'll hear from some of you soon so I can give you feedback. All right. We all have a good day.